Okay, this is a question from lesson 90, the notes. We went through it in class already, but there were a few requests for me to put a video online for it so that it can be viewed again, and you guys know exactly how it works. This is the x plus 3 over an x minus 1 minus an x plus 5 over an x squared plus an 8x minus a 9. The first thing we should notice is that the denominators are not the same. And before you can add or subtract fractions, the denominators must be the same. That should be an x. So I have to make common denominators first. Since this is a trinomial, I should first think to factor this. I'm looking for numbers that multiply together to give me a negative 9, but add together to give me a positive 8. And those numbers are a negative 1 times a 9. So I would factor that into, first fraction stays the same, add an x plus 3 over an x minus 1 minus, this is so messy, let's try that again, an x plus 3 over an x minus 1 minus an x plus 5 over an x minus 1 times an x plus 9. The next thing I should notice is on this right side I have an x minus 1. In order to make this denominator the same, I would have to multiply it by an x plus 9. But whatever I do to the top, I have to do to the bottom. Now I have fractions which have the same denominator. I'll just rewrite those over again. X plus 9 times an x plus 3 over an x plus 9 times an x minus 1 being subtracted from an x plus 5 over an x minus 1 times an x plus 9. Okay, so as you can see, the denominators of both of these fractions are the same now. Excellent. We can begin to simplify. First thing I'm going to do is just write this over one denominator. Whenever I have a subtraction sign, that's got to be distributed to both of the terms that are following, because this is one group here. That's going to become a minus x and a minus 5. So I'm just going to rewrite that over here. X plus 9 times an x plus 3 minus an x minus a 5. And I'm writing that all over the one denominator. Perfect. Now that I have that, I can begin to simplify here. I've got these terms off to the side, in which I know I'm going to be able to combine them with something here. But as long as these are still as binomials, I'm not going to be able to combine anything. I have to distribute so that I can combine like terms. I'll take the x times the x, which is going to give me an x squared. X times a 3 is going to give me a 3x. 9 times the x is going to give me a 9x. And then the 9 times 3 would give me a 27. So what I did was took this and rewrote it over in this way. But I can't forget about that minus x and minus 5 that were already up there. I'm just going to tack those on to the end. Minus x and a minus 5. Denominator's still the same here. I'm just doing one step at a time, simplifying one thing at a time, and then rewriting everything over. Now I can begin to combine my like terms here. I have this x squared, which doesn't have anything that I can add or subtract with it. There are no like terms there, so that's going to stay the x squared. I then have a 3x, a 9x, and a minus x. Well, 3x's plus 9x's is 12x's, and 12x's minus 1x is going to give me a positive 11x. I then have this 27 minus this 5. Those are like terms I can combine, and 27 minus 5 is 22. And that still goes over an x plus 9 times an x minus 1. Now at this point what I should ask myself is, can the top be factored? Since this is a trinomial, whenever you see a trinomial you want to ask yourself if it can be factored. I would look for numbers that multiply together to give me that positive 22, but add together to give me a positive 11. Well, my factors of 22 are 2 and 11. Those are my only two factors. And if I were to add those together, it's not going to give me an 11. So I know this cannot be factored. Since it can't be factored any farther, it means I cannot simplify anything. I am done. I will stop right here. This is my solution. It doesn't get any smaller than that.